Okay, so welcome to this session where we're going to discuss the relationship of alcohol content and, along with a number of other things in relationship to ripening and wine phenolics and sensory attributes. And it's a pleasure for us to have here today with us Dr. Jim Harbison. So Jim is an associate professor up at Washington State University. He's based in the Tri-Cities. And he received his bachelor's in biochemistry and his PhD from UC Davis. Jim's research focuses on phenolic compounds found in grapes and wine and their biochemical and chemical changes. Jim serves on in a number of capacities on a number of professional organizations. He serves as the associate editor for the Australian Journal of Grape and Wine Research, and he also serves on the board as ASEV. In fact, he's the current president of the ASEV. And he's also been awarded the Best Enology Paper from the American Journal of Enology and Viticulture 3 times. So he's well researched and a lot of really interesting work. And so it's great to have him down here in Oregon to talk to you about this particular topic. So with that, I'm going to hand over to Jim, and he's going to take it from there.
Thanks, Jim. Cool. Thank you. Fantastic. So glad to be here. There's a first disclaimer on my talk. There's no Pinot Noir in it. I'm sorry. Not in any Chardonnay. So this may be a little bit different. So I have a disclaimer at the end that my research results sort of apply to those of us in Eastern Washington. So hopefully, though, you can get something out of it. But before we start this, I want to have a sort of a show of hands. I have 2 laser pointers. I have kind of the red one. We're going to call it the Sith color, and then we have the Jedi color from Yoda here. So get Vader or Yoda. Which one do you guys pick? Vader. It's hard to argue with Yoda. It really is. We're going to have to go with Yoda. I'll use both of them occasionally. I'll switch back and forth, make people happy. Okay, good. So as you can see here, the title of my presentation is quite different than the one that you probably have on the outside of the session. And that's because we all know that ripening has a lot of effects. And so some of the effects that we're going to talk about are, as Jim said, about phenolic compounds. And some of them are going to be about the effects of alcohol. And I think when you get to the end of the presentation and we start talking about the effects of alcohol, I think this is where most of you are going to give me either the really skeptical look or the crazy look, or I don't know, maybe I need to go sit down and have a heavy drink. But I'm happy to have a heavy drink with you later on. I'm down from Washington for the day, so I have a nice evening. Anyways, so we'll get going here. I have this title from Linda Besson. She's the king, or the queen, really, the retired queen now of making titles for me. It initially was something like the impact of ripening on phenolics, or something like that, and she changed it and made it look really much cooler than whatever I would have dreamed up. So, introduction here. So I think really what I want to get at is that in grape ripening, there's heavy influence on wine composition. We're all taught these things at school. We're all taught ripening the berries. There's these obvious effects that happen. Sugar gets higher, you get more alcohol, flavors develop, you get more flavors as you have more ripe fruit. In fact, most people tell you that you can taste the flavors in the fruit while it's ripening. How many of you guys think that? Yeah? I mean, that's kind of what we've all been told, and when people talk about making picking decisions, this is not any slight against anybody, just when we make picking decisions, it's about these flavor development and things like that, color, all these sorts of things. But I want to talk about here is that these fruit and wine relationships are a lot more complicated than we give them credit for. Not many of these relationships are what we call in the WYSIWYG. I know many of you are going, what? WYSIWYG. And that refers to is what you see is what you get. And it's kind of a modern thing that we sort of kind of put things in acronyms like this, I suppose, but it's not that modern. We sort of like to make things simple when we don't have too many words. But as you learn today, things don't actually work as what you see is what you get in many cases, all right? So, complex relationships. As you guys know, many times, especially when you're making those picking decisions about what you're picking depending on the cultivar, a lot of those wonderful flavors are bound up as precursors. In Washington, this is a little bit easier argument to make because lots of people pick Merlot, lots of people pick Cabernet, and you know when you go out to the vineyard that your fruit doesn't taste anything like your wine. When you're tasting Cabernet fruit, it has no bearing on what it tastes like. It just kind of maybe you're looking for the absence of veggie flavors or something of this nature. Some of these flavors, though, in certain cultivars, they are really there. And that's because you guys all know that a lot of your flavor compounds are bound up as precursors, right? So they have a sugar attached to them, and you can't actually taste them simply because they're not volatile, right? They're not actually going to be doing their game with your receptors in your retronasal cavity, etc. So we do know that a lot of these flavor compounds are affected and changed during ripening. So we know some really good examples are things like methoxypyrazines, IBMP, that's that acronym thing again. TDN. How many of you guys are familiar with TDN? I know that some of you guys probably make Riesling here. All right. So that's that carotenoid compound that's found in the skins of the grape, right? But when it gets heated up, or it goes through a structural rearrangement, loses some water compounds, and then suddenly you get diesel aroma, right? Which is something that most people think of as being a wonderful aged Riesling character, but not one you want to have in your young Riesling wine, right? But again, this is a complicated relationship because it depends on how much heat you had in the vineyard to how much TDN you might develop in the wine, which is a different one than we're most used to dealing with. The methoxypyrazine story, we sort of think of as being you give the fruit sun exposure during ripening, and then suddenly these compounds are either photodegraded or they're lost, right? And so we don't get that veggie flavor in our wines due to our ripening. So, again, not so simple. So how does wine composition affect all these things? Well, we know that alcohol acts as a solvent for many of the things that we actually are able to smell, right? So the things that we get to sniff in our wine all have to be in the headspace, and that means alcohol is controlling a partitioning coefficient that allows these things to either be in the headspace or not. So depending on how much alcohol is there, is going to control how much of these things that we are ripening to get gets up in your in the headspace of the wine, so you can actually smell it. Okay. Okay. So I guess I pushed the forward. Okay, there we go. So tannin and color, again, more complicated stuff. So with tannin, we've known for several years now that when we measure fruit tannin and we look at wine tannin, even if we break things out based on skins and seeds and we do a lot of sort of dissection, kind of like we're forensic scientists or something, and we try to build relationships with the fruit and the wine, we find that these relationships are terrible. In fact, they're so bad that I've only put a couple in research papers because most of the time when you don't have a good correlation coefficient, they just won't let you put it in the paper. And even though that's a really important finding to say that there's no relationship between fruit tannin and wine tannin. I know that I've probably got some stunned silence because a lot of you probably don't think that's completely true. Sorry to say, there's a lot of things in the fruit that actually make it not work that straightforward. So there's a lot of these complex cell wall components, polysaccharides. They more or less form a sponge of components that more or less have to be satisfied or bound up before you can actually get wine tannin or any wine tannin at all in the wine. So you have to bind up this sort of pre-fining agent that's actually present there. And if you have the pleasure of being someone who makes French-American hybrids, you also have the pleasure of having PR proteins, pathogen-related proteins or pathogenesis-related proteins that are present there as well, and you have polysaccharides to deal with, and you have these proteins. So you have two sponges to deal with, which is why a lot of times when you get French-American hybrid wines, they don't have any tannin in them at all because they can't actually exceed the size of the sponge that is existing in the fruit to begin with. Okay, no, and the tannin salespeople are out there trying to get the tannin into these wines, and they've been suffering with it for many years and haven't been able to get there because the sponge is too big. Now, again, that is a very complicated relationship, right? Some of these things we probably don't even measure most of the time. So we know that alcohol has some influence on that extraction. A little bit, maybe depending on the cultivar you're working with, you can see some big increases in extraction. But most of us were taught at school, more alcohol equals more tannin extraction. How many of you guys heard that? I know I did. Yeah? Okay, that's kind of the general idea, that more alcohol equals more extraction, typically more seed extraction, right? So, now, that's just the tannins. What about color? Color is, again, another one of these complicated things. We know from the work from Roger Bolton down at UC Davis that this relationship is really kind of not straightforward. You have co-pigmentation, where you get more color that you can visually see based on the concentration that's there. You get a lot more that you can actually make the relationship between the amount of color that you see versus the actual pigment concentration, because there's cofactors and all these other things that give you an enhanced color. So much farther and beyond what you would actually get based on the concentration. So Roger has more or less suggested to me that some of these same effects that we see with these cell walls for tannins possibly are playing a role in what kind of extraction we can get from color as well. Possibly why we see some really nice effects from enzymatic treatments. I saw a couple of those in the hall before I came up here. There was some pretty striking examples of someone using an enzyme and then getting a really big difference in the color. I don't know if you guys actually tasted those wines, but they're quite striking. In the case of pigments, though, alcohol, and I can confirm this, has no effect on extraction. Okay, so how does fruit composition influence polymeric pigment production? So as you guys probably are aware, polymeric pigments are the stable color that we see in old wines, and they occur as a result of interactions between tannins and anthocyanins, and maybe some anthocyanins and some other kinds of compounds. But for the most part, we know that it's really the tannins and the anthocyanins making these components. So they are wonderful colors because they are unaffected by pH changes and bisulfite bleaching, which you do see to get with normal pigments. Again, there was a really cool experiment downstairs where somebody added no SO2 and SO2 to a wine, and the wine that had no SO2 had a really bright color, and the one that had SO2 was bleached out. We kind of expect that that's going to go away over time, but there's a lot of really cool experiments downstairs, I guess is what I'm getting at. You should taste those wines, they're pretty neat. But anyways, we know that these polymeric pigments, or at least we believe that these things actually modify mouthfeel of wine over time. So when we're tasting young red wines, that they are often quite astringent and harsh, but as the wine ages, you are forming more of these polymeric pigments that have apparently a different ability to behave with their astringency than the normal tannins would. And the idea is that astringency is essentially caused by tannins interacting with your salivary proteins and binding them up and precipitating. Normally they would be lubricating the inside of your mouth. The idea is that these polymeric pigments, or pigmented tannins, have a lesser affinity for these proteins than normal tannins would, and thus cause you to have a softer type of perception of astringency or a lower astringency. And so these are not just important from a color standpoint because of the color that we get over time, but they're also important for the softening of astringency. So a lot of winemakers often talk to me about, well, how do I predict what kind of color I'm going to get over time? How do I maximize this polymeric pigment formation, especially for those of us in Washington where we're making very tannic wines? They want to know, how do I balance this out? How do I get a lot of polymeric pigment and not have to be very stringent? And how do I balance these out? And so some of the research that's out there has often suggested that there are magical anthocyanin to tannin ratios between these two compounds that will give you a great polymeric pigment production. When I looked in the literature to find this out, I'd heard this many times, I'd read it in textbooks. There actually weren't any papers that had done any research into it in any way, shape, or form that I could find. So, of course, I had to endeavor and do this myself. And that's what you're going to see next. So, in order to do this, we thought, well, how do you want to study anthocyanin to tannin ratios? You want to get more pigments, you want to get more tannins. How's the best way to do this? Well, the first way most people talk to me about is, well, why don't you pick as many different wines as you can, like Cabernets or maybe Pinot Noirs, whatever, and then look and see early on during the development how much tannin is there, how much anthocyanin, and watch how that relationship builds out. The unfortunate part is that you can't necessarily pin that down onto that cultivar or anything else because the way those grapes were grown is different, maybe the way those wines were made were different, et cetera, et cetera, et cetera. So I couldn't actually do research like that and hope to get it published. So what do I do instead? Well, instead I rely upon ripening to change the relationship as the fruit ripens, because we know that both anthocyanins and tannins do change during ripening. Now, whether or not you get more tannins or less tannins during ripening in the wine, we don't really understand. But for pigments, we're pretty sure it works pretty straightforward. The riper the fruit gets, the more pigment you tend to get into the wine. So we decided, well, let's use ripening as a way to do it. And not only that, we can corner off any sorts of other effects that we would imagine would have a change on our things. Vigor, all this stuff, it all comes from the same vineyard. We're controlling the winemaking. We can do everything. And so we chose not only different ripeness, but we also chose cultivars that we know are inherently different in terms of the kinds of wines that they make. They make more pigment in them or more tannin. We use Cabernet Sauvignon, well, because Cabernet is the king in Washington. It's the most widely planted red. It makes economic sense. And not only that, it has lots of pigment and it has lots of tannin. Syrah is also very important in Washington, although not the same as Cabernet, but it usually tends to have a lot of pigment and not so much tannin. So we can pick two different kinds and we can do different ripeness, right? So we picked fruit at, I would say, historically unripe ripe and overripe sugar concentrations, if you will, soluble solid. So 20 Brix representing underripe, although this was perfectly ripe, 20, 30 years ago when winemaking was still making wines were 12%, right? So if you want to call that 20 Brix wine old school winemaking, 24 Brix really new school, and the 28 Brix is kind of, I call it port school, where you're making 16 to 17% alcohol in it. I think that's kind of the sort of the way I've characterized this experiment. And these represent not just different alcohol concentrations, but really different eras of winemaking decisions, if you will, okay? So the other part about this experiment that we did that probably will throw many of you for a loop is that we did things that are completely and utterly illegal in most wineries. We controlled for alcohol at each harvest because I knew that alcohol was going to have an effect on supposedly the extraction of phenolics. So that meant at 20 Brix, I'm going to chaptalize with 4% sugar to make it to 24 Brix, and then 8% sugar to make it to 28 Brix, right? And then when I got to 24 Brix, well, that meant I had to chaptalize up to 28. And then I had to do the trick that many consultants many years taught me ago to bleed off and water back down to the lower Brix, but bleeding off such that I actually calculated how much I was going to change the volume first, bled that off, and then went back to diluted. Okay, so you guys are probably familiar with that trick. I'm certain. I see some shaking heads, so good. Okay, so that way we could get wines at each harvest point representing all the different eras of winemaking. So we could sort of get not just the alcohol effect, but we could also get the changes in the pigments and tannins. So you could get unripe fruit that's going to have more alcohol there, hoping to get more tannin extraction, et cetera. So we could get lots and lots of different ratios of anthocyanins to tannins in the wine. So here it is just in a graphical format, just in case you didn't catch all that I was describing, but I'm going to attempt to use the laser pointer now. Okay, so you guys are maybe not hearing me, but here it is. So you have unripe 20, 24, 28, 24, ripe 20, 24, 28, 28 Brix, 20, 24, 28. Okay? So completely controlled for alcohol. Now this looks really straightforward and simple when I draw it up on the chart like that, but actually doing this is not trivial. It's really, really hard. In fact, the first time we made the, I think 60 to 80 Brix concentrate solution of sugar to do this, the sugar crashed out in the center. We had a giant iceberg of sugar, and we ended up staying till like 1 in the morning getting all our chaptalization and things actually done. So these are long-suffering experiments. There are a lot of work to do these things. Okay. So here's a picture of the winery we're actually doing this in. So these are at the Wine Science Center in Richland, Washington. We have these 220-liter scale fermentation systems with 54 total wines. We're using the so-called T.J. Rogers Bolton fermenters, which have automated everything. They're the closest thing to Star Trek for making wine that I've ever seen before. They have automated pump over and Brix meters and all sorts of things on them. Lots of bells and whistles and lots of temperature control, which is pretty nice for doing these kinds of experiments. The beauty of this facility is I have 192 of these little fermenters. And we can actually do a lot of fermentations, essentially, which is nice for me because I like to do layered experiments. So here's the winemaking protocol. We had to use EC 1118. I know that's not everybody's choice, but we had to in this case because we need to get to pretty high alcohol concentrations, and it's probably the only yeast strain that comfortably ferments up to 18% alcohol without even blinking. We also did simultaneous ML on this, 48 hours post using VP41. It works for us pretty well. For us on a small scale winemaking, it really works easily because we can take advantage of the heat that we generate from primary and actually get the ML to happen pretty rapidly. We did some nutrient additions. In Washington, we have very low nutrients in our grapes. Typically, we see about maybe 50 milligrams per liter of yeast available nitrogen at most, so we tend to do very liberal additions of diammonium phosphate, not because we want to, just because we want our ferments to go. And so we're usually targeting about 225 yeast available nitrogen, milligrams per liter yeast available nitrogen, okay? So we didn't do any acid adjustments at all during this experiment, mostly because I knew that acid was going to change a lot, and I decided from the outset I would just let it be what it was and just not mess with it. Okay, 10-day maceration for everything too, okay? This experiment, I didn't also apply some extended maceration treatments as well, although we have done those in the past, so it's not that complicated. Okay, so one of the first questions I said about, well, how does anthocyanin and tannins influence how the wine ages, right? Well, normally you expect wine to be aging, maybe 4 to 5 years before you're going to come up with what you expect to be where the wine's going to be when it's produced all of its polymeric pigment, maybe even 20 years, right? Well, I am an academic, and I confess I must use graduate students and PhD students to do my kinds of experiments, and there's not one of them that I've ever talked to ever that would be convinced of staying that long. They're barely even interested in staying 5 years. So I had to figure out a different way to go about this aging thing so I could keep my graduate students pleased and maybe actually even willing to do the experiment. So we did an automatic aging experiment where we heated the wine to 30 degrees. And this essentially, for every month that it's at 30 degrees, essentially it represents about a year in bottle. So we did this for 4 months, and that way we could represent over time as the wine ages. And you'll get to see those plots in a minute. We also removed all the other components from the wine. So we just collected the phenolic side of there by using a special kind of column. And that way we could evaluate polymeric pigment production and anthocyanin decline and tannin changes in a clean system that we started with from the wines. Because a lot of people actually, some of the other ways you could do this experiment, you could extract tannins from skins and seeds and all sorts of things, but that's actually really difficult. This way actually makes a lot more sense. And I'm glad we did it this way because we're going to find out some other stuff later on just because we did it this way, that you wouldn't otherwise do it. Okay, so we analyzed for polymeric pigments using bisulfite bleaching, protein precipitation, and we also used HPLC to do this analysis. So here's the harvest data for this. So the first thing my graduate student learned was also making picking choices is actually really, really hard. You think it's so straightforward, and you get things, and it looks like the fruit sample is going to tell you what it is, and then it's much different in the winery once you crush the fruit. But you have to learn the hard way. She knows how to do it now, though. So we picked on day of the year 233 for the Cabernet Sauvignon for unripe, 260, so plenty of time in between there to get up to 24 Brix, and then another 28, 29 days to get to overripe fruit. So we got 19, 2, 25, 1, and around 27.5 Brix for this experiment for Cab. Similarly, our Syrah was a little bit riper earlier, 20 Brix at 231, 252, a little bit faster to get to 24 Brix, 24.5 though, and then 27.9 at day 286. So the Syrah ripened a little bit faster than the Cabernet Sauvignon. You can kind of see the sorts of the things you expect to see when you have fruit ripen. The pH goes up, mostly due to the exchange of potassium for protons that's happening in the fruit, especially at the latter stages of ripening. The TA is declining, especially precipitously so in the Syrah. And the berry weight, again, is with Cabernet is going up and then oscillating right back down to where you were at 20 Brix. So that's just showing that most of the change that you're getting between 24 to 28 is really due to dehydration of the fruit, not so much accumulation of sugar. Similarly with the Syrah, the precipitous decline in that berry size at the very end of ripening. With Syrah, it's really hard to get an accurate berry size, I would say. I think we normally use about 200 berries for doing these kind of experiments, and I honestly think that you might want to use 600 because there's a lot of shrivel in Syrah that occurs even at like 18 to 21 Brix. You're starting to see some of the berries actually shriveling. So I think that first piece of data there is a little bit on the wonky side, personally. It should be actually going up in size, not actually already peaking out and then declining from that point forward. Okay. So here's the initial wine phenolic data. So we have for the Cabernet Sauvignon, we have the unripe fruit getting for all wines across there, about 371 milligrams per liter. As you're getting the fruit more ripe, for 260, for 289, there really isn't any difference in the amount of anthocyanin. Actually, if I go back, did I talk about that? I didn't talk about this. Okay, I have to go back to this. I'm sorry. So the last column there is anthocyanins, and for Cab, basically the pigment goes up and then comes down. So it starts low and then ends up kind of peaking out at 24 Brix and then coming back down at 28 Brix. And then for the Syrah, it actually kind of goes up and also comes down and peaks. There's a lot of speculation about why we think we see this drop in color, whether it be that the cells in between the skin and the pulp are starting to deteriorate and it's letting loose oxidative enzymes that actually just getting in there and actually destroying some of this pigment, as you would expect it to actually just concentrate just the way the Brix does, right? Well, Thankfully, most of the time you sort of think of that wine as it gets riper, you're getting more pigment in it, but the color data would suggest otherwise. And thankfully for the wines, they actually suggest otherwise as well. You're actually getting more pigment in the wines. So here's the Cabernet. So for the Cabernet, it's not even changing anything, even though the pigment concentration according to how much you would have in the fruit is going down. As you see here, there's no difference in the amount of anthocyanins in the wines there at all, okay? So again, this relationship between fruit and wine for pigments, the way you expect to be straightforward, isn't. Now for the tannins actually start out high and end up declining as you're getting more ripe fruit for the Cabernet, although it's not much difference between 24 and 28. But the key for us was that we're making different ratios of tannins to anthocyanins, or anthocyanins to tannins. So it's about 0.36 and then gets up to about 0.93 and 0.86 for as you ripen the fruit. For the alcohol treatments, which is actually trying to change the tannins, we're hoping we're going to get more tannin extraction. You can see that for anthocyanins, there is no effect. Sorry. And for the tannins, there is only effect when you get up to 16% alcohol. So between 12 and 14% alcohol, essentially there's no difference in these wines for the tannin extraction. Whereas when you get to 16%, there's definitely an increase, a kick up of tannin as a result of having higher alcohol there. And again, you're changing the anthocyanin tannin ratio due to the fact that you're extracting more tannin. So the wines that have more alcohol in them have a slightly lower anthocyanin tannin ratio by virtue of having more tannin in them. So for the Syrahs, we have another sort of way of looking at this, another kind of relationship. So the pigments start low, they get a little bit higher, and then they get even higher, right? So if you kind of remember what we showed in the fruit earlier, it actually went the other way, right? The fruit started low, got to a certain point, and then actually declined. In this case, the wines actually show a completely different scenario. So again, that relationship is not so great. For tannins, there is an increase overall as the Syrah, so it's a very different sort of trend than you're seeing in Cabernet. You're actually getting more tannin on the later harvest wine. But in this case, the ratios are up between 1.3 and 2. So with comparing that to the Cabernet Sauvignon, which is around 0.3 or about 1, maybe at the riper fruit, you're actually seeing almost a double of relationship in Syrah. Twice as many anthocyanins to tannins are present in the Syrah. And again, with the effect of alcohol, no effect on color, but only a small effect in the Syrah, where you're seeing it basically between 12 to 14%. So there isn't really, I guess, a straightforward rule about how alcohol affects the extraction in fruit. In Syrah, it just goes from 12 to 14, then you see a difference. With Cabernet, it was between 14 and 16 where we saw the difference, right? So again, these relationships are more complicated than we expect them to be. But we also see that ratio changing, so 2 to 1 at low and declining thereafter. Okay, so how's the anthocyanin changing over time? It's starting out with it's basically, you're seeing a big sort of logarithmic decline in the amount of pigment in these wines as they're artificially aging. You're seeing it in the unripe fruit, they're down at the bottom where it's starting out with a lower amount, and the overripe and unripe fruit are essentially right on top of each other, showing that in this case, this is an exponential decay taking about 4 months to completely go away. So you actually would have no free anthocyanin left in this at all. It's basically all gone and made into polymeric pigments. So here's the polymeric pigment formation over time. So here's the Syrahs, and here's the Cabernet Sauvignons. And essentially, you are getting, for the most part, the effect is not due to alcohol, but due to picking decisions. So the unripe, in the case of the Syrah, is the one on the top. The ripe and the overripe's the one on the top. The ripe's in the middle, and the underripe is at the bottom. And so they're all kind of forming, essentially, most of their transformation happens within the first month. That would translate to being the first year for you guys, and then flattening out that point forward, even though there's a little bit left in terms of anthocyanin. Most of the change is really happening in the first year of aging. So when we actually tried to build relationships now between how much pigment in the fruit, or how much pigment was in the wine compared to these different ratios, what we found was essentially the best relationship was between just the amount of pigment that you had in the wine to begin with and total polymeric pigment production. So nothing to do with the ratios. Actually, the ratios weren't that great in terms of predicting how much total color you were going to get. It was really just about how much color you had there to begin with. I know many of you are probably thinking intuitively, you've already kind of guessed this, right? By making wines, you know that when you have more color in them, typically, you're going to get better color over time. Well, that your intuition is actually correct. When you dig into the numbers a little bit, you start to see that maybe tannin starts to build a relationship a little bit. In the Syrah, when you add the two factors together to try to get a little bit prediction, you can see that it actually gets a little bit better when you add the tannin to that relationship. For Cabernet, it doesn't really matter because there's so much tannin there to begin with. But in cultivars that are starved of tannin like Syrah is, you have to have a little bit more tannin to make those polymeric pigments. I would hesitate to guess that in a scenario like Pinot Noir down here in Oregon, where you are starved of, well, from our perspective and from Syrah and Cabernet, you're starved really of both pigment and tannin, to be honest with you. But I think you might want to consider just trying to get as much as both of those things as possible into your wine if you want to get a lot of polymeric pigment production over time, although it may not matter for Pinot Noir so much, to be honest with you. So, the conclusions of this was essentially anthocyanin concentration was the best single predictor of long-term polymeric pigment production. Polymeric pigment formations occurs really rapidly, right? I know you guys are probably thinking, where on earth is alcohol going to get us into this discussion about sensory? We're going to get there. So, now, I started doing this experiment a little bit earlier, and it took a long time to get to the sensory on this because the people that were doing the sensory were in another country. But we did this one with Merlot because Merlot is the big other red fruit in Washington. And in this case, we did the same kind of experiment. You'll have to excuse my Mac computer for butchering the fonts here. It took 21 days to get from unripe. We're going to do the same trick again for ripe and overripe. But in this case, we've got 21 days and then 37 days. So it took, a good 60 days practically to go from underripe to ripe. Okay? I want you to keep that number in mind as we progress through this story about what happens to the wines, because this is going to be on sensory, not on color and not on these other parts, all right? Same tricks we did, the chaptalization, the bleed off the waterbacks, all that stuff. More or less the same kind of winemaking, a little bit different tank. And here's some of the fruit data. Now you've kind of been seeing this sort of thing already, where you're getting fruit ripening and you're getting more Brix there, you're seeing a pH changes. With this Merlot fruit that we've looked at this a few times with, you get some counterintuitive effects. You get actually a weird sort of effect of concentrating of titratable acidity. With Merlot, it tends to hold its acid. You don't tend to lose a lot of malic during that 24 to 28 ripening steps. You actually see an increase in titratable acidity with Merlot. It's a little bit different from some of those other cultivars we have. But you're seeing sort of the same kinds of effects on color, though. Increase in color as the fruit gets riper. Tannins and seeds and sins, we're not going to bother with that data later on, but it's just there for you to see. But I want you to kind of get at is that there's some intuitive effects here and some counterintuitive effects. And it's intuitive that the berry size is going to go up and then decline, right? But it's not intuitive that there's going to be a concentrating effect on acid. And it actually strikes a lot of winemakers in Washington that they don't have to do a lot of acid adjustments, even though they are really ripening the heck out of their fruit, because their fruit holds their acid pretty well. So when we get to the part with the alcohol here, I want you to notice that we added some components to these wine measurements that we didn't have here before. So we added, in this case, dynamic viscosity of these wines. So when we have unripe versus ripe versus overripe wines, there's a small change in dynamic viscosity, kind of starting at, she labels them different than I do, but unripe has the highest, and then ripe has the lowest, and the overripe is in between. When you have the alcohol effect, you're seeing that dynamic viscosity goes up as the wine has more alcohol in it, okay? So there's an effect of both ripening. So your overripe fruit has sort of a lower or kind of in between for dynamic viscosity as effect of the ripening itself, but alcohol is really controlling it. So the more alcohol you have, the more viscosity that you get in the wine, okay? This is kind of, again, intuitive. We would kind of guess these things. So these wines also had differences in color and things of that nature. Pigments going up as the fruit's getting riper, kind of maxing out at around ripe and overripe. There's a little bit of difference there. And similar to what we saw with, are totally different than the Merlot and Cabernet, or the Cabernet and the Syrah, you have the ripe having the least amount of tannin and the overripe having the greatest amount of tannin. So each of these cultivars behave differently as a result of ripening the fruit, right? So we saw Cab kind of declining as the fruit got riper, Syrah getting more tannin in it as the fruit got riper, and for Merlot, more tannin in the fruit as the fruit gets riper, although there's a low point with the ripe fruit. As effective alcohol for Merlot, we're seeing that essentially the highest alcohol concentration actually differentiates it between the 12 and the 14 for the tannin extraction. So Merlot and Cabernet behave very similar to each other in terms of alcohol and its effect on tannin extraction. Now, the sensory portion of this work. So I had seen some results in this experiment earlier in a previous experiment, and I decided I didn't want to do them myself because I knew that part of this is going to be kind of counterintuitive to those of most of you in the audience when I get to it. I sent these wines down to Hildegard Heyman down at UC Davis, and she had a Fulbright scholar, Emma Sherman, from University of Auckland that she wanted to do some experiments, and I had wine, so it was great. They did a lot of descriptive analysis on these for everything from sourness, bitterness, astringency, and sweet body, and they also did a lot of aroma things. I just have listed off a few of these here for you. Vegetal, bell pepper, smoky, white pepper, floral, spice, red plum, red fruit, dried fruit, oak. So I want you to kind of note that these wines never saw any barrels at all. So this is sort of a testament that some of these oak aroma compounds are kind of pleasant already in our fruit, and probably many times why our certain cultivars do better in barrels than other ones. But I also want you to note that those are kind of the transition between what flavors that we would normally associate with being ripe or underripe Merlot, right? So you can kind of see the gambit's already there. Veggie, bell pepper, probably representing these unripe fruit, and then all the way over here to red fruit, plum, dried fruit for some of these riper fruit characteristics. Okay, so they did a lot of different attributes. But it all boils down, I think, really to this one principal component analysis. All right, I'm kind of seeing some blank looks out here. So how many of you guys are familiar with principal component analysis? All right, well, that's better than what I expected. But essentially, what a principal component analysis is that we want to integrate all the different characters, the sensory characters and attributes of the wine that we rated, right? We want to look them all together because when as people, we integrate everything together when we're tasting wine, right? We're not just tasting one attribute at a time. And so the PCA kind of allows us to model out all that data statistically together so we can sort of integrate where these different wines would have in terms of these different components that we're rating. You've all probably seen these before. And what we have here is sort of two plots. One of them has, on the left, has where the wines are, and then on the right, it has where all the attributes are in terms of where the vectors for those specific characteristics map out in terms of the math, okay? So let's just pay attention to the PCA with the vectors, all right? So on the left-hand side of it, well, actually, it would be, my left-hand side. I'll just go with that. It has the closer to where the bell pepper, the earthy, the vegetal, the sour, and the lemon. Those all kind of haunt over in that one section. Towards the center, you get a little bit more veggie, a little bit earthy, and over on the other side of the plot is almost all the things we associate with riper characteristics. You have bitter, white pepper, smoky, alcohol, maybe hot, body, oak, spice, dried fruit, red fruit, floral, plum, all those kinds of characteristics, all right? But what's interesting about this is when you actually map where these wines, which are these ellipses on the other plot here, they're all separating out based on alcohol, not when you pick the fruit. So over on the left side of this plot, you have all of the low alcohol wines. In the center of the plot, here, these are all the medium alcohol wines. And over on the right, they're a little bit spread out a little bit. You have the high alcohol wines. So at the top, there's that high alcohol, and then down here, you have the other two ones. They're more or less sitting on top of each other. So what this is really suggesting is that alcohol is controlling our perception of these components and not ripening. All right? So that meant when we picked fruit at 20 Brix, and we waited a good 60 days, right? Which was how long it took for it to get from 20 to 28 Brix. If we just added 8% sugar to that 20 Brix, we could make it sort of smell very similar to something that we picked 60 days later. So 60 days of ripening didn't happen, but the wines, due to the fact that there's 4% more alcohol there, smell a lot more like the overripe wines that we picked 60 days later, all right? Similar for the 28s, or for the 24s, and similar to the 20s. So this relationship stood up all the way across the line. Now, the one that kind of sticks out a little bit is the first harvest wine. It's a little bit different than the other two. The other two sit on top of each other a little bit more cleanly. But I think that what this illustrates is very clear. Alcohol is controlling what we're smelling in the wine, not what we're getting from the ripening. All right, I know that a lot of people probably don't necessarily agree with me about that because it's all about, even I was taught this at school, as you ripen fruit, there's a lot of flavor transformations and things that are going on, and that's what's making veggie go away, right? So here's a case where we had 20 Brix fruit that would have tasted veggie, except for you add 4% alcohol to it, and then suddenly it doesn't taste veggie anymore. In fact, it tastes fruity, right? So the partitioning of what these components are going on is to do with alcohol. So I think this is one where we always talk to kind of go back to the Overlook Hotel with Jack Nicholson in The Shining. That's kind of what I was thinking when I first got these results, because this is a little bit weird. So, but I think what he's holding in his hand there is kind of a good way to think about how this is actually working. How many of you in the audience have ever consumed whiskey or gin or anything like this? All right, everybody here in the audience has done so. Good. Okay, so it won't surprise you to know that when you are a distiller, someone who's standing at the still, and you're trying to make decisions about which cuts you're making coming off the still, what do? You cut it with water, right? Because when you add the water to the alcohol, it forces all the hydrophobic compounds, which are the things that we can actually smell, into the headspace. You then quickly put your nose over it and go, oh, that's tails because it's burning my nose, or I mean my heads, it's burning my nose, cut that, whatever, or if it smells good, then we're keeping that in the hearts, etc. But the water is the best way to actually get it to it quickly because it's forcing everything that's trapped in the alcohol into the headspace. Okay? So, essentially, what we're really looking at here is a tendency of a molecule to partition between liquid and vapor phases. And this is Henry's law, if you will. And essentially, we're using Henry's law in essentially a fairly dilute system, alcohol versus the aroma compounds. What we're looking at mostly is the effect of how much water is there. And I went through and calculated how much water would be different based on alcohol concentrations. But I think suffice to say, the part of the story that's really the important part here is that it's not all straightforward the way we were taught at school, right? Ripening equals more ripe flavors, yada, yada, yada. These relationships are not straightforward, okay? So most of us think that the veggie in the fruit is it's all about the sunlight's photodegradation. That's what's changing these veggie compounds, and that's what makes us, when we wait later to pick, that's why we have less veggie wines, right? Well, it didn't turn out to be this case. It turns out to be really alcohol that's controlling this. And from my perspective, that's actually a pretty cool thing, because that means it's pretty easy after the fact as a winemaker to control alcohol, right? You can de-alcoholize, pretty straightforward, it's pretty easy. RO units are becoming cheaper. You can actually have them mobile. You can bring them to your winery. You can change, ostensibly, the aromatic character of your wine by simply mucking around with alcohol. Blending also affords you a very similar kind of effect. You can blend with things that have higher alcohol in them, right? Because that can help you change the aromatic composition of your wine pretty dramatically. And that's a really great thing from my perspective in terms of being a tool for you as winemakers to help make better, different kinds of wines. I don't care about the sort of dogma that we're kicking around here with the flavor changes during fruit development. I would hazard a guess that we'll probably find that some of these things, there's a really easy relationship between what's in the fruit and what's in the wine, but some of them it won't. I'm okay with that. But I think the more important part here is really recognizing that alcohol has a much greater role than we maybe initially had given it in terms of our perception of what's in the wine. And that is really the take-home message here. We're actually undergoing a lot of research to figure out what these compounds are that are changing in there from the QTOF. Emma Sherman was just an absolute wonderful person to work with. She actually did a lot of stuff on trying to understand what the relationship between the compounds that were in our aroma standards that we were giving people to say that tastes like tobacco or bitter or whatever, and then actually looking into the wine to see if those same compounds were there to figure out can we actually say those things that they're very similar, and actually we could. There were nice, good standards that we actually used for them, actually found between both the wine and the strain standards that you normally cook up in your laboratories. But yeah, it's really about the alcohol. So I think when you integrate these things, which is a lot of times what people ask me to do, is you integrate all of the characteristics of these wines, not just the aromas and flavors, but also the color, which is a big part of why people pick up wines and decide to buy them or not. We're seeing two different stories here, right? Alcohol is controlling not the color extraction, right? But alcohol has a little bit of effect depending on whether you're Cabernet for higher alcohol, you get a little different tannin extraction, right? But it's really the pigment concentration that's driving this. And even though the relationship between the fruit and the wine, pigment, one that you couldn't necessarily make a good choice from getting fruit data from somebody, you're actually getting more color typically when you have riper fruit, right? That gives you more pigment in the wine, you're getting more alcohol, less veggie characters in the wine. Essentially, around the world, whenever I go places, this is what people think of as being, to them, better wine. I don't think that's always the case everywhere that I've gone. I was just in the Margaret River doing this presentation, and every wine that I tasted there that they thought was high quality, in fact, they're selling it for quite a lot of money and getting good ratings, is all veggie. Granted, this is because they only have veggie clones in this place. They only have 2 clones of Cab. One of them, they can't get the veg out no matter what they do. But still, so beauty is in the eye of the beholder, I guess, is really what this is really getting at. From the American palate, I would guess that veggie is not such a great thing. We've gone to great lengths in California of getting veggie out of wines. And here I'm showing you kind of some of the things about why people have essentially decided to ripen fruit longer, because empirically it happens that way. Whether the reasons that are there, it's coming down to alcohol, maybe more so than ripening, but that's kind of what we've seen in our experiments. All right. Again, I have the disclaimer there at the end here. These results may not apply to other cultivars and regions, because I know I'm in the land of Pinot, not as much as I'd like to have some Pinot Noir grapes to work with at times. It's very difficult for me to get them where I'm at in Richland. So, now that you're all stunned, I have some acknowledgments to make, all the people that actually did the work, the people that invited me to come down here to talk to you guys about this rather kind of controversial kind of style of work that we've been doing, my funding sources, and all the people that do these, between my graduate students, my colleagues, and my funding sources, the Wine Advisory Committee, the Washington Wine Commission, the Washington Grape and Wine Research Program, and the WSU Agriculture and Research Center, where I was working when I did some of this work. Okay, so I've got one anonymous question on a text. I can change gears. I have more information as I usually do. I wondered if people might get bored with this. But any questions? So I can answer this one via the text first if you guys like, and if you guys don't have any questions, I can go get a drink. It's okay, I can do that.
If you have other questions, and we do have mics up here, we'll repeat the question so that we can hear it. Otherwise, Jim's got some that are being texted in as well.
Sure. So it says, so if you were to harvest earlier, chaptalize to get riper flavors, if you were to then de-alc it, would the flavors revert to greener flavors? Good question. In fact, I have an experiment that I'm actually conducting this year to do this, because the same question was, in fact, the same exact question was asked to me numerous times by winemakers in Washington when I first showed them the results. So we're planning to do this with white fruit and with red fruit, and we are actually have de-alc treatments being applied all at 24 Brix and 28 Brix to bring it down to 20, so 12% and 14% alcohol every time. Okay, so the idea is that you get more alcohol, get the change in the aroma, and then de-alc. Now, as you can imagine, de-alking probably strips some things out, as you can imagine. So there's going to be some effects. You're going to probably have to add some of the permeate back depending on how you're doing it. But I would guess that you will get the green aroma back. But you have to do the experiment, right, before you can prove it. So I'm going to guess. I'm going to put my M&M. If I'm going to guess and bet, I'm going to bet my bag of M&Ms like I used to with my mentor many years ago. I'm putting my M&Ms on the coming of the veggie compound come back when you lower the alcohol. But you have to do the experiment to figure it out, though. I don't see anybody rushing up to ask a question. This is a lot of very concerned faces, though.
Would evaporative loss, like in barrel aging, maturing, would that impact sensory profiles?
Yes, you would expect it would, actually. In fact, I was talking to my friend. We both like to drink bourbon a lot. And I'm often really flabbergasted to learn the one that I like to spend a lot of money on is the one that's the barrel at the bottom of the warehouse. And the one that's cheaper is the one that sits at the top of the warehouse and evaporates more alcohol. So yeah, I think that alcohol evaporation certainly would change it. And I think more than anything, it's really due to our perception of these things. So it may be that there are slight differences in concentration, but you've got a lot of effects coming just from how we perceive these aroma compounds in the headspace of these wines. So yeah, I think it would have an effect for sure. Uh-huh. Uh-huh. Going to force me to go all the way to the back. Yeah, but it doesn't look really different between the overripe and the ripe for this, to be honest with you, in terms of the decline of the pigments. So yeah, they kind of sit on top of each other. Well, this may speak to certain differences between cultivars. So Cab is known for having a fairly thick skin. There's actually I'm not sure if anybody's actually looked at the number of layers of cells that are there, but there's definitely a difference between cultivars and the thickness of the skin and how it breaks down or not. With Cab, we know that there's even the pulp of the fruit forms like a sheath around the seeds, and it actually takes, several days before that sheath starts to fall apart and then release those seeds so that you can actually get seed tannin extraction from wine. Other cultivars, I remember at Davis we did amphilography classes, and I think there was this cultivar called Burger, and it was the one that we all knew on the exam if there was any fruit there that we could pick it out almost immediately, because Burger had no pulp in the berry whatsoever. It just had seeds sort of floating in liquid. And you could walk up to a Burger berry and flick it and it would explode. So that was an easy one on the exam, and you knew that was Burger every time, because there's what I guess is I'm getting at is there's a lot of genetic variation between cultivars in terms of how the pulp looks, how the skins look, etc. And that's certainly true of French American hybrids and even some of the rootstock types that have slip skins and all sorts of things. So it wouldn't surprise me that maybe Pinot Noir had a little bit thinner skin, deteriorates a little bit faster, even to the point where you may start to see some of these hallmark pigments happening a little bit production, maybe even in the fruit itself. Okay. Oh, well, there's way more questions now. All right, great. Is there a noticeable difference in perception if you adjust alcohol before or after fermentation? Good question. I don't know. Yeah, I don't know. Again, this would be whether or not you couldn't really do it after the fermentation, because you'd have to have the alcohol present there for the earlier one, so you'd actually have to adjust, etc. So we couldn't really do it that way. I did have a lot of people ask me that before too. If you added distilled alcohol instead of chaptalizing, it would have a similar effect. Well, I actually have had that one asked as well, and you don't ever really get pure alcohol. Even with people that are drinking vodka and things like that, there's a lot of things that come in there. And so, especially with the budget that I have, they won't pay for me to have a still where I would be happy to have my own perfectly clean alcohol that you could add to it. I'd be very concerned that you would be adding other stuff. And not only that, the way that we've done the experiment with the bleed-off and waterbacks, we've actually assured ourselves that the ratio between the skins and the seeds and everything is identical for every fermentation. And that's one of the other reasons you did it that way, as opposed to if you added just straight up alcohol, you then change the total volume of the system, right? And that would mean that the concentrations of all these components would change concomitantly. And that would then you'd have a concentration effect as well as an alcohol effect. And so by doing it the way we've done it, we've actually avoided having any concentration effects due to addition of anything, okay? So it made it, from my perspective, a little bit cleaner in terms of the math. It made it so it was more straightforward for us. Okay, good question. Okay.
Do you think this is going to have a large effect on what we use to determine ripeness of fruit? So we're no longer going to be taking Brix maybe, and it'll be based more on the acids and other components in the fruit?
Maybe. I don't know. I never totally know how the results that I have from experiments actually have an effect on anybody. They usually have an effect on me. But I don't always know how other people are going to react to them. A lot of the places that I looked at in Washington, when I first told them these results, was basically I had a show of hands of how many people actually believed me, and there was a pretty sizable contingent that did not believe me whatsoever. So, so I honestly think that might be the case. That if alcohol was a target, though, you'd still need to have sugar. If really what you're looking for is the alcohol concentration is really driving the ripe characters you're getting, then you'd want to actually be paying attention to sugar. Acids, again, though, you're always going to be in need of measuring those things no matter what, because that's one of those very few measurable things you can do in the winery that actually has an honestly clear-cut relationship to something that we can do for sensory, right? TA has a very strong influence on sourness. So it's really a good measurement to have, to do. Never avoid that one. So yeah, I would maybe make picking decisions on that with the sugar, sure. We're just back to where we were, right? We're always measuring sugar and acids. These are reasons why they've stuck around for so long, is because they actually work, right? Very clear-cut ones, too. Okay. Was the effect on sensory perception equally distributed between aroma and taste, or was one affected more than the other? This is a really good question, actually. We can go back to the sensory plot, because we actually have those separated out by mouth and by nose, essentially. And it's, if you kind of look at this section on the left-hand side, you'll see that there's I think that's an F by all of those. I'm trying to think of why would she would use F as opposed to nose and mouth. I think F is for flavor, and A is for aroma. So that would mean that all the veggie things on the other side are integrated when you put things in your mouth. And so that would suggest that the biggest driver here is actually integrating the whole thing and not just what you smell. So it's actually a retronasal cavity effect and not just from smelling it. Okay, so this is both things integrated. And actually that means it's more of a powerful effect than just simply what we were describing earlier, okay? Okay. Are these effects modulated by residual sugar? How would this translate into effects of fortified wines? Another good question. Well, we kind of have a little bit of residual sugar effects already, if you kind of look at it. We tried really hard to ferment these things, but when you get to really high alcohol, even EC 1118 starts to peter out on you. So if you kind of look down there at the bottom, it ends up being around 6 grams per liter, which is not really dry, in my opinion. But it was good enough for what we could do here, considering how much alcohol we were doing. I don't know. I think that there's some strange things when we look at port wines in terms of pigment and tannin effects. There's some really weird things with ports, the way that those are chaptalized. I hesitate to say what factors actually cause that. I've always wanted to study port because it has some really interesting and different pigments in it that you don't get in normal wines. Actually, they age a lot longer, and I've often thought that the sugar itself behaves as an antioxidant in this case because there's high enough concentrations of sugar to behave like an antioxidant. So I don't know, though, for sure. I don't know, but I think it's an interesting thing to pursue for sure. So thanks for asking that. Did the tasters note a perceptible quality difference between the chaptalized wine and the control at the same alcohol? We didn't actually ask them any hedonistic questions. And in fact, we tried to avoid those kinds of things because that might actually color the way that they actually rate the wines. We wanted to avoid having them change their opinion about anything to rate them cleanly. So we didn't actually ask them of that. But I think that most people would sort of expect that the wines that you've added a bunch of sugar to maybe don't have the same kinds of qualities to them. I don't know. People have been chaptalizing wine in France for a very, very long time. In fact, when this first study came out, I had a lot of emails from folks over in France who wanted to have French versions of this written. Actually, they're asking me to write it in French, which there's not a lot of hope that that's ever going to happen. But I could see why, because they're probably trying to search for some of the reasons why they do some of these chaptalization effects, because they actually do this. Maybe it's illegal, maybe they do it anyways. It happens in a lot of wine regions around the world. I think Australia has just got around to finally legalizing the addition of water, which they've probably been doing surreptitiously for the past 20 years. So there are a lot of times we're looking for these reasons about why we do these things. So I have a feeling that there's still some nice benefits from chaptalizing, and it's not all negative ones, as we might guess. Like if you add bagged acid or something like that, we all know that you get sort of weird characters when you add things to wine, right? I don't know if it's the same for sugar because it gets chemically and it gets metabolized and transformed. So you might not have the same kinds of negative effects that you would associate from adding other kinds of things because there's actual metabolism happening. Okay. You guys are really anonymous, aren't you? Okay. Do you think these results could be applied to flavors imparted by different yeast strains or just tannins and anthocyanins? Oof. Yes, but I don't understand the question. Tannins and anthocyanins. Yeah, anyway, so we'll just go with yeah, sure, that's fine, yeah. Sorry. You'll have to come up to me afterwards and ask the question again. Maybe I'll understand it a little bit more clearly then. That's just why there's lots of anonymous things, so then people don't confuse me in public and then feel silly, right? Because I feel silly when I have to not know what you've asked, unfortunately. Okay, somebody ask a question by raising your hand, please.
I have a quick question, Jim, about saigne. About saigne.
Uh-huh.
That doing saigne, with your experiments doing saigne without doing water add back, is that an approach or a way to get more pigment, to concentrate polymer pigment?
Yes, saigne without waterback. Actually, we've done some experiments in Washington. The first iterations of me doing saigne waterbacks where the consultants had first come to Washington and had suggested that you could ripen fruit for a very long time, and then, but if you took it into the winery, you would add a bunch of water back, right? And that meant you would dilute it. And so all that dehydration that you had out go on in the vineyard was essentially going to be canceled out by the water you had to add in the winery to get it to a reasonable sugar concentration you'd expect it to ferment. So what their suggestion was you should bleed off first before you do the water back, right? Which is what we're doing in our experiment. Well, not for nefarious reasons, though, of cheating vineyard owners out of valuable money that they would be getting from tonnage, right? Sorry, that was not me. I didn't say that. What we learned was that it didn't really give you a benefit to color when you did it that way. But if you bled a lot off, in fact, you have to bleed almost 18 to 20% off of juice before you do the saigne to actually get a benefit, appreciable benefit in color to the wines.
Without a water back?
Without a water back. You have to do, it's a really big bleed off. So if you're going to do a bleed off water back where you're trying to do that trick, double the volume you bleed off and make some, what do you call it, pasta water rosé with whatever you bled off. Don't kill the fish, because the sugar going down the drain is a bad idea, but it will benefit your color, okay? We've done those experiments. We've actually done them quite a lot of times because that question comes up a lot. A lot of times when I see people doing saigne is because they think that it's a bad year is coming for color, and so they kind of overreact sometimes and bleed off everything because they think it's going to be bad color and then end up sacrificing a bunch of juice. So I would suggest maybe doing one trial lot at the beginning of your ferments. Maybe do one saigne, one not saigne, and see if you really get an appreciable color difference. If not, you can throw a lot of money away if you can't make a lot of money off that rosé that you're making on the side. Oh, another question. I'm not familiar with the descriptive panel you used. Had they been trained together and worked together extensively versus, example, a student panel? Wow, that's a kettle of fish you just opened up there. Boy. So, contrary to popular belief, winemakers don't actually make the best panelists doing sensory, mostly because they come with preconceived notions about what things are and they are not. In fact, we've had people come and tell us that we over-oaked wine really badly when the wine had never seen oak in its entire life. In fact, we don't own any barrels in our facility because they're too expensive. I just can't have them. And so when I'm having a winemaker coming and tell me that the wine's over-oaked, I think they need to have their heads checked. Still, I think it's an important thing about when you're doing sensory, though, that you're right. You want to have people that are trained. In fact, that's why we had the people with the standards going back there and making sure that the things that they were in the standards that they were smelling were actually the same things that were in the wine, which I thought was actually a valuable step in me believing the data as well. But they were reproducible. I mean, if they're not reproducible when you do the statistics, the judges, they're not good at what they're doing. If they're not acting like little machines like we train them to be, they fall out of the panel. In fact, their data is kicked out because they're not reproducible. So we actually make them taste several times, lots of times, before they actually get the wines, and they're trained a little bit with a small amount of the wine beforehand, so they kind of have a sense of what they're getting into. And Hildegard Heyman wrote the book. I don't know if you guys know this, but the whole book on the sensory evaluation of all sorts of things, Hildegard is the main author on that book, and it's an amazing book. If you haven't read it before, it's got like, I think, 5,000 scientific paper citations, something of that nature. So, and she's a wonderful researcher, and that's why I sent them to her, because I knew these wines were going to cause controversy. I knew some of these effects might be seen, and I wanted to make sure that I had somebody who's known for being a sensory professional doing it, and not myself, who I am a mere neophyte in comparison to her. Question answered, I hope?
What was the name of that book again?
Oh, I think it's Heyman and Lawless. Let me get back to you. I can look that. Maybe we got Google here. We can probably find it. I don't know. I don't remember this kind of stuff because there's too many other things going on in my head. Children, work, presentation times. Okay. I hope you're not recording this.
If there's any last questions? When Jim's finished Googling, we'll take the last question.
Sensory evaluation of foods, principles and practices. There you go.
Last question over there.
Okay, last question. A portion of it, when they were doing the flavor and aroma portion, was done in black glasses. I thought. I think you're right, though. I think there is certainly an amount of connection, but I think the best part about having students and maybe grad students who don't have years and years of experience of connecting sour things to veggie flavors and then making those connections, that they're free of those things, and that they can actually experience these wines as what they are, as opposed to with all of the baggage that comes along with experience. Good, bad, or indifferent, right? But it's scientific instruments, when you have baggage, it's actually worse, to be honest with you. Alan.
Jim, I want to ask you to, in some ways, critique your own experiment here, because what you present is contrary to sort of a lot of common experience and a lot of common sense. Not necessarily
Common sense, thank you. I'm
Well,
contrary to common sense.
Common sense.
I love it when I am contrary to common sense.
Common sense is not necessarily true. Surely, as a berry goes from underripe to overripe, there's a change in the components. The aroma precursors, the amino acids, the terpenoids, the fatty acids, and so the components which give rise to flavor in the mature wine are changing in composition and extractability. And you show, but in the high alcohol extraction, the early ripeners stand aside from the mid to late ripe in your principal component analysis.
You want me to answer?
What?
Do you want me to answer? You're still
No,
going?
no. So, but I'm coming to the question. I'm asking you: is there some subtlety in wine aroma or flavor that your approach and your analysis misses? Because we know high alcohol wines from different vineyards differ in flavor, differ in value, different value in the marketplace. Is it possible that there's something missing from some part of a study that would actually help reinforce the prejudices of people who are skeptical?
All right, well, I will, you had a very long question there, and there's a lot of parts about it that are in there that I find interesting. So one of the things that is about this experiment that blew my mind was that we are taught that there's a lot of chemical transformations and changes in the composition of the fruit as the fruit ripens, right? So you're getting more of certain compounds, maybe twofold factor, right? maybe threefold. Maybe you might even get lucky and get tenfold increase. So what I think that's awful about all this is that alcohol, because of how much you actually are changing it by, ends up utterly and totally swamping out because there's just so much more mass. So much more mass. We're talking millimolar concentrations of alcohol that are changing versus, I don't know, nanomole, picomole, micromole for a lot of these flavor compounds. So it just may be that even though there are these things changing that are happening in the fruit, that we are actually happening, it's just that they don't matter compared to the effect of alcohol that just utterly blows it out of the water. Or not, in this case, which is sort of the point of the experiment. I don't know if I could have done the experiment in some other way to prove people what they think is true. I don't think that's why I do my experiments, Alan. I'm sorry. I don't know what to tell you about that one. I do my experiments to find I don't even know what the outcome is going to be. I don't ever have a preconceived notion about what the experiment outcome is going to be, because if I know I do, it will ruin the experiment. So I just let the results be what they are. In fact, I even divorce myself of parts of it to purposely avoid having any influence on the outcome of the results. I try to, it is what it is, even if it's an unpopular result, which clearly sometimes to people, if it's not common sense that I've found when I've done my research, that it just comes out a different way. And maybe sometimes when we crash through these barriers, we start to find other ways of approaching what's going on, because clearly this is the beginning of a road in terms of trying to figure out what the effect of alcohol is, and maybe the changes that are actually going on through ripening that change things and don't change things, which things matter and which ones don't. So I don't think this is the end all and be all of all experiments. In fact, I'm already planning this one, as I suggested before, where we're actually going to do some de-alking, and we're going to do it on white grapes and we're going to do it on red grapes. And if there's a grape that you can imagine is going to be dominated by something just by aroma, it is a white wine, right? White wines present themselves very straightforward compared to reds most of the time. You can often tell very quickly the character of a wine within a few seconds of sitting with it. And if we're going to see some effect from alcohol on that, I expect to see it from there. And so that's why we're going to approach it with a de-alc as well, and we're going to go, granted we can't get to 28 Brix with any white cultivars in Washington that I've ever come across, so we're going to have to maybe get to 26 if we're lucky with some of them. Maybe Sauvignon Blanc might be courteous enough to do us that. I'm hoping that we could actually even potentially do this with genomics involved, where you're doing things that are parental relationships like Cabernet Sauvignon and Sauvignon Blanc between these two, so you could actually attach some of the metabolomics and the genomics aspect of this to try to dig a little bit deeper, as Alan is suggesting, into some of these other transformations. But hey, we just found out something new and we're going to dig into it, right, Alan? It's okay, even if it's not common sense, right? All right.
Okay, so I think we're going to wrap it up for the session, but if you've got any further questions for Jim, I'm sure he can hang around the podium here for a little bit longer, but just like to thank Jim for his presentation, for coming down here, and we'll see you all in the wine soiree for the next hour or so.
All right,
afterwards.
excellent. Thanks, everybody.